Now here's another thing, it's super easy to make what's called night core. Maybe I want to make some night core here, so I just go back here and I do 10,000 instead of 8,000. Here we go. Dang, this is another level. Yo people, what's going on? Thanks for coming back to another episode of Aura Audio, and today we're going to be doing something special. I'm going to be unveiling a new series called Data Structures on the Gameboy Advance. And in this series, I'm going to be learning some data structures along with you, which is going to help me therefore teach those to you and help me learn those. As well as we're going to have some fun and not just, do simple problems, but we're going to look at what are some practical applications for these data structures. Let's get started. Today, we live in a world that revolves around data. I mean, all the Instagram stories you get, all the messages from your friends, all of that data has to be transferred somehow, right? Well, an important data structure in transferring data between systems, whether audio data, music, whatever, is a buffer. A buffer is a fixed data point on a system, a fixed size that allows us to temporarily put data through that buffer and move it to somewhere else. And today, I'm going to be showing you how to utilize the buffer on the Game Boy Advance. And the reason I said utilize is because we don't actually have to create this. Buffers are in hardware implementations as well, and that's what I think is so cool about them. To get you set up, I'm going to link you 3 resources. The first one is a program that will convert raw audio data into an array of C bytes. And the second one is a website by an associate professor that will help you learn about this sound. And the third one is a repo I created with some already existing code that I will explain. Another resource you'll also need in order to compile everything in the end is the DevKit Pro or DevKit ARM toolchain. And I have plenty of videos on how to set that up, so go ahead and check out this one right here, and that should help you get started. If it's not the right one, you can look for the one for your system and go ahead and set up that tool chain. Super important. So to start, let's go ahead and open up the music GBA file or folder, and we'll go ahead and go to source and open up template.c inside a code editor of your choosing. Now what this file does is it has all the necessary code you need to play a sound on the Game Boy Advance, whether it's a music file, a sound effects file, or any other file you can think of. And the reason this is useful is because one user, William Drum, commented, "How can I play a sound while the game is playing?" Because for those of you who don't know, this thing cannot multitask. In other words, it only has one thread on its CPU that is responsible for all tasks. So how does it do multiple things like play sound and let you play the game at once? Well, the way it does that is through cool tricks such as direct memory access. This is a layer of the system that allows us to go directly from one area of memory to the next memory without having to bother the CPU. So the first thing we're going to do is we're going to look, what is this master sound? Well, this master sound is a register in the Game Boy Advance that allows us to control what is happening with the sound hardware. Or rather, it's the way we enable it. And the second one here is the sound controls. So this is how we actually control the sound. And these two things here are called FIFO buffers. Now, what is a FIFO buffer? Well, FIFO or FIFO stands for first in, first out. And this means whatever goes in is the first to go out. So that's kind of a very useful structure that you can use to move things in and out of a system really quickly. And another one is a DMA register. So these are the registers we're going to be accessing to use that data or to transfer that data. So we got the DMA source, the DMA destination, and the DMA control. And next we have our timer registers. So we need something to drive that data transfer, something that's responsible for telling us how fast are we transferring this. And that is going to be what we use the timers for. And here we have some macros that tell us what bits do we need to have on or off in order for some setting. So this is going to enable the sound right here. And this is going to say we're using sound A on the right channel, and we're using sound A on the left channel, and we're using sound A FIFO reset, sound B, etc., etc. So these are setting all the reset and the channel properties. And next down here we have a register that enables the direct memory access. That's something we also usually do on this system, is if we want to do something, then we enable that thing that we want to do. And next we have the DMA destination fixed. So that means we're just going to keep the destination the same. You do have the ability to change it, but maybe we'll leave that for another video. We also have DMA repeat, so it will automatically repeat as many transfers as it needs. And we also have how much bits do we want to transfer. Well, we're going to do transfer by word. And also the timer is what's responsible. So once this timer overflows, that's how it knows that it's done a DMA transfer. And it will just keep doing that literally until you move past the data. And that's something we'll have fun with later. And I'll show you what happens when you don't stop the data transfer. And finally down here, we have all the different frequencies that the timer can run at. So 1 is going to default to the CPU speed, which is 16,777,216 ticks per second. So that's the amount of times that timer is going to be counting per second. Now inside our main function here, which is what runs on the program, for those of you C programmers out there, you know that main is the entry point of a function. So all of our code for the program is basically right here. First thing we do is we reset the timer, we reset the DMA, just in case anything else was in there. And next thing we do is we specify that we want to use the sound A right channel and the sound A left channel. And we also want to reset the buffer that's inside there, the FIFO buffer, or FIFO. And next thing we want to do after that is enable the sound, because otherwise, no sound. And with the DMA, all we have to do is set our DMA source, which you'll notice this blank include up here, which we're going to use later to specify a linked file that we're going to use as our music file. And down here, we'll include the definition, the identifier of that file, so we can have the DMA source point to that. And the DMA destination is going to be that FIFO buffer, the one we discussed earlier that we don't even have to implement. And finally, with the DMA, we're going to set the control so we have all of the properties we discussed above. Now is the fun part, where we actually specify what we want the audio to do. So let's say I want a file that has a sample rate of 8,000 samples per second. Now the sample rate is basically what describes how fast the file is playing. And if you have a file that has a sample rate of 8,000 samples per second and you play it at 8,000 samples per second, well then you're going to get a file that sounds like it's supposed to. And we also have the clock, so that's going to determine, okay, we have this many ticks per second from the CPU. So what are the ticks per sample? Well, the ticks per sample is this clock divided by the sample rate, and that's going to give us how fast we need to set that timer. So for the timer data, all we have to do is set it so every time it's going below its maximum to minus ticks per sample. So it only goes so much so that we have it at the right timing interval. And that's going to give us the ticks we need in order to play the file correctly. And finally, we have timer control, which is going to enable it and set the frequency of the timer accordingly. And last but not least, we actually need to keep the program running. Even though we have all this right here, well, it's not enough to keep the program running, because as we discussed earlier, this actually isn't using the CPU. So we need some way to keep the CPU awake. And that's by running an infinite while loop. And there it is. That's the whole program. So next thing we want to do is convert our music program so it's actually suitable, or our music file, so it's suitable to play on the Game Boy Advance. So how we do that is first we can get a music file. So I'm going to look all the way through my downloads here until I find something. Maybe I might as well do one of the music that I use in my YouTube videos. So I'm going to do this one, Storms by Stay Loose. And all I have to do is drag that MP3 file into Audacity. And now you can see it has stereo, 44/100 hertz, and then 32-bit float. So this right here is saying this is a stereo file. So you know when you get the left and right channels, that's why it's called stereo. And then the 44/100 is the sample rate. So that specifies what sample rate this file was recorded at. And down here we have the 32-bit float. So that's the data type. That's basically in audio your dynamic range. So that means you have 32 or 2 to the 32 possible steps in your dynamic range. So what we want to do is pretty much downsize this file, because right now, first of all, the Game Boy Advance cannot play 32-bit floats, unfortunately. It only does 8-bit, which I think actually sounds kind of cooler. And we also want to narrow down that file size. So to do that, we can downsample the file. And finally, we're just going to play mono files. I may do another episode where we use stereo, but for now, we're going to do mono. So all we have to do is go to tracks, mix down to mono, and then we can do mix or resample, and I'm going to do 8,000 hertz. Awesome. So now we've already done that, and we just do file, export audio, and make sure you do raw headerless signed 8-bit PCM. And we can just name this Storms and no dash Stay Loose. Just like that. And save it. Awesome. So now if we go to our folder here, this GBA folder, we should see a new file in there. And that is the Stay Loose file. So all we have to do is take this audio right here, and we go to raw GBA, go here, and now I'm going to open this inside terminal because we're going to have to make this. So I think all we do is say make, and make sure you have make installed on your system. So what you have to do if you don't is you do xcode select install, and mine says that I already have those tools installed. So whatever system you're on, you need make in order to make stuff. So yeah. All right, so now that we did that, we can do ls, and we could see we have this program raw to GBA. So all you have to do is say /raw to GBA, and then storms stay loose .raw. Awesome. So what that basically did is that converted this into a header file that we can then go ahead and use. Did this convert that to... I think this thinks that it's the wrong sample rate, so I'm going to downsize that, and let's try and export this again, actually. Sorry about that. So go to export audio and Storms Stay Loose, replace, because that file size, that was too big. That looked way too big. So I'm gonna go back, and there we go. See, 1.4 megabytes. That's better. So now I'm gonna go back to here, replace this one, then I'm gonna do the same thing. It's going to replace that header file. So now look at that, only 9 megabytes, and that includes a bunch of text stuff. So that's why it's a little bit bigger. Awesome. So now we can go back to our program and just stick this right in the source folder. And then we go back to the code. We can say include storms stay loose .h. And then down here, we say storms stay loose. And now that we know the sample rate, we can say that's correct. So we go ahead, we go back to our main folder, and then we do cd, is it music GBA? Awesome, yeah. And then we can do make. And there we go. Our file is made. So now what I do is I take my SD card along with an Easy Flash Omega. So right now the SD card is there. I take this, I put it in my USB drive, and then I plug it into my computer. And then what we do next is we can put this file right here. And I already have one called that, so I'm going to replace it, then eject it, take it out, put this back into the Easy Flash, put that in my Gameboy Advance, power it up. You probably couldn't hear that because it was too quiet. Now all we have to do is load the program. So if I go all the way down to the Music GBA program and press play, this is what it's going to sound like. That reverb too, it's clear. Now check out what happens next. So right there, it's just plain random crap that basically isn't the audio file. So we basically ran past the boundary of where that data was. And yeah, that's why we don't have a way to stop it yet, but we really should. Now here's another thing. It's super easy to make what's called nightcore. All we have to do is change the sample rate. So let's go ahead and do that. If we go back to Visual Studio Code, maybe I want to make some nightcore here. So I just go back here and I do 10,000 instead of 8,000. And now, since it's playing that at 10,000 and we recorded it at 8,000, it's actually going to be a little bit faster. So if we go back here and we say make, there we go. And then we can go back and do this thing, switch out the file, and then put this thing here, plug it back my USB. Awesome. So now we can drag this guy right there, replace, eject. Now it's going to sound like nightcore. If you don't know what nightcore is, it's basically a faster, pitched up version of any song, so pretty straightforward. Alright, I'm excited. Here we go. Dang, this is another level. Turn those synths up, yeah. That's it for this episode. I hope you guys enjoy, learn something new, and I will see you in the next one. Peace.